So I'm just going to talk for a few minutes, I think, about changing my gearbox on my Losmandy G11 T RA drive. So just kind of how this is designed. You've got a motor. The motor has a pinion. The pinion goes into this little transfer gearbox. Or, well, I don't know what you want to call it, but I got to call it something. So I'm going to call it the motor gearbox. The motor gearbox steps down the speed and drives this gear here. And this, the transfer gearbox. So we've got the input, which is this gear here from the motor and the motor gearbox. We've got this transfer gear, and then this gear here fits on the worm gear, and this spins the worm gear and obviously rotates the RA or the deck if it's the deck worm gear. The problem with this, the original gearbox here was it was made of plastic, and you know, I had the T version of the Losmandy G11, which is rated 100 pounds for the payload. And about a 65 pound payload on there just shattered the plastic gearbox. I've got it in a bucket somewhere, but trust me, it's completely shattered. So, so that didn't work. And they make a, and I'll post the instructions. This guy, Michael's a really nice guy, has it all figured out and has instructions for having this metal gearbox installed. Now, it's not as simple as it seems. That's why I'm making this video. I could do it. I've done it. I'm going to run it for you right here before, you know, in a second. But I'm just going to tell you kind of the challenges. The first challenge is if this tucked-in motor, you know, you can kind of drive yourself nuts and go reach this bolt with an Allen key. The Allen key you've got to use has to be one with the bell grooved out, because you're not going to get in there with the straight Allen key. They sell them on Amazon.com. I got a set of them right over here somewhere. I actually like these Allen keys. And you can tell they've got these little grooves, these little bells on the bottom. And that allows you to get in from an angle. So you can go drive yourself nuts and go in and pull this motor off the motor gearbox that way. And I highly recommend not doing that. I did it, actually, and it drove me nuts. The easiest way is to just take this mounting plate off. So you just go to the worm. This bolts onto the worm gear. Just take this plate off. So take this plate off. Take these four, well, I'll be specific. Take this plate off. Pull this gear off. Then you have access to the 4 bolts. Pull the 4 bolts off and just pull this whole thing off, because it's a lot easier to access when it's just sitting on your bench. Now, just kind of some lessons learned here. So you get the gearbox, costs 35 bucks or something like that. I got 4 of them because I have 2 of these Losmandy G11s, and therefore I have 4 of the plastic gears. I'm not sure I'm going to bother ever changing the decks drives, but I might. So 35 bucks, whatever. I bought 4 of them. Now, problem number 1 is the pinion is a different size than the pinion that's on this motor. So you've got to get a little pinion puller. You can get them on Amazon and pull the pinion off. Be patient. And the other thing too, on the pinion puller, the dimensions don't line up right. So you actually have to shave the pinion puller plate down so it actually fits in there and you can make it all work. And I used a Dremel and just ground it out. It worked pretty well, actually. So that's how I recommend doing that. So that worked. So ground down the pinion puller, pulled the pinion. The pinion that comes with this gearbox has a different inner diameter. So you have to drill out the inner diameter, take a little super glue, put it on, put the pinion on, make sure the pinion gets flat. I use these clamps to clamp things in, because what you can't do is, there's a couple things you cannot do, and that is have Loctite Red or super glue go where it's not supposed to go. It's number 1 thing you can't do, because if it gets in the gears or back into the motor, forget it. You're done. So that's one thing you gotta watch for. And the other thing is you can't be banging. So you need this stuff to set up in a fairly orthogonal way. So, you can't have it on an angle, and so you got to put pressure on it, and, you need it all the way in. You always use these clamps, and I clamp to something because there's no thrust bearings in any of this stuff. So there's no thrust bearings in the gearbox. There's no thrust bearings in the motor. So if you put too much thrust on there, it's just gonna not be very helpful. So you got to change the pinion puller. You've got to take this gearbox apart, pull aside the gears, and then drill out the holes for these bolts, because the holes aren't the right size. Then you've got these little ears here. Well, the ears need to be elongated. So the inner diameter of these ears isn't sufficient to give you enough play on this to get rid of the backlash here. So you actually have to grind out the inner diameter of those ears. And I used, back to my Dremel, I just put on the jeweler's engraving tool and just ground out the inner diameter, so it's sufficient. Now, the other thing I found was that nothing really wanted to line up properly. And the way that the Losmandy guys deal with that, with the stock equipment, is they've got like these extended bolts, these hex bolts, and I just abandoned those. So I abandoned the cover for this. Like, in my mind, that cover served one purpose, which was to cover up the plastic gearbox. So they put a plastic gearbox in there. The way to, like, not have that be offensive was just to cover it up with this metal cover, held in place by these hex gears. But the hex bolts actually had a second role, which was to control the tension that got put on this bolt that goes through the aforementioned ears. So what I did was I just got rid of that, and I put some nice washers, some compression washers here. Belleville washers, if you want. I've got a bunch of them. They're on Amazon. You're like $11. You get a kit. It'll last you a lifetime. And so that's how I mated this gearbox to here, was the washer and the bolts directly. And then what I also found was that the motor with the motor pinion didn't really want to line up exactly properly inside the new motor gearbox. And so you can see I used the same bolts. These are the bolts, but I shimmed. I shimmed it so it fit exactly how I wanted it to fit inside this gearbox. And the shims, I mean, I just got, that's just brass, and I just cut it in my workshop and put them in there. You could do a lot more elegant shim job than I did, but it works. So now I'm sitting here, and you can see, like, there's no backlash in these gears. Everything's true. Everything's parallel to each other, which is what you got to have. The other thing I did was, you can see there's a set screw. Oh, so the other thing is, the drive shaft that comes out of the new motor gearbox has an outer diameter that's smaller than the inner diameter of this gear. So you've got to take a piece of copper tubing, and it's in the instructions that are posted, but I think it's 4 millimeters and 5 millimeters. So I took the copper tubing and I basically ground it to fit. So I went, had the bench grinder, just thin the outer diameter a little bit, so it just fit perfectly inside. You can't even tell it's there. Like, there's actually a little piece, like a little copper sleeve in there. Now, the problem with that is, then you've got this set screw. And the set screw, first of all, the one it came with is little tiny and evaporated. And so I went and got the same number 4 40 threads per inch set screw that uses this very inconvenient 0.05 inch thing. I didn't even know they made these. The only time I've ever used one my whole life. So I just basically went and got a longer one. So instead of it being under 1/4 inch, it was tiny. I don't even know what it was. It was tiny inches. I got one that you can see. You maybe you'll see it in there. See that thing sticking up? And sticking out like that's just fine, because it actually provides more bite. This bites better, and you can actually turn it. With the little one like this, it really had a hard time controlling the set screw. And the problem is, of course, is between the shaft and the set screw, you had the copper sleeve. So you had to drill through the copper sleeve. So, and then I re-tapped it. Little tap, put that in there and tapped it out. So the set screw could go all the way through the bearing, or the gear, and through the copper sleeve and drive home, sit home on the shaft, because you can't have this thing spin. And I actually tried to super glue it just because, you know, I'm like, I really didn't care if I could take it off or put it back again. That didn't work. The other thing that's, you know, in addition to the pinion pullers, it's kind of nice you've got a pair of bearing pullers lying around too. You know, this is a pretty handy little device. Like, it doesn't really cost very much. So, you know, whenever I needed to pull this off, I used the bearing puller because I didn't want it to deform this gear. And, you know, I tried a few things, you know, I had it on and off half a dozen times before I figured it all out. Yeah, and so that's why you'll see too, when I pressed it back on, you know, I did it this way too, so I didn't put any stress on the motor gearbox or the motor pinion and shaft, drive shaft. What else? So just kind of going through the thing, I took this, I pulled the pinion off, I drilled out the pinion, I put the pinion on with a little super glue. I controlled the pinion drive into this gearbox with the shims. The gearbox, I needed to be both tight onto this plate, but also sufficiently scooched so there's no backlash here. And then, you know, it needs to be tight. It can't move around. That's why I just use these bolts and a compression washer. And here I kept the original bolts, but shimmed it so I could control the mating of the motor pinion to this motor gearbox. I'm going to get rid of these gears altogether and just put a little belt drive in here like you see in most telescope mounts. Well, I'll do that. I'll do that a little later after I get this whole thing working and I'm done spending time on this silly thing. Now I actually lubricate these. I highly recommend lubricating them. This is the lubricant I use, and I think it's mentioned in Michael's write-up, but the CRC brake and caliper grease. It's a synthetic grease, and what I like in my telescope greases is for them to have graphite in them. And this does have graphite, and I have a little tube of extra graphite in case I want to go nuts. Just because graphite's a real good dry lubricant. And it doesn't migrate, and if it does migrate, it's not gonna make a big mess of itself. Because in these telescopes, you need these gears in the worm gear. I lubricated the worm gear, and I lubricated the worm gear wheel that drives the RA. So I cleaned it up, put that lubricant on. But you don't want too much lubricant because you don't want it getting hot and drippy and running all over and getting on your clutch plates, and it could really be a nuisance if you let the lubricant migrate too far. And in some other telescope mounts, they could migrate on encoder electronics, and you know, really, you don't want the lubricant all over the place. You want it where you need it. And I'm a little heavy-handed on my lubricant, so here I am. I'm just going to go prove that this all works. What other little tricks were there? Here I drove. You can see like I have very good control over with this little tiny thing over this set screw. And again, I drilled out the sleeve, that copper sleeve that was in there, so the set screw now mates directly on the drive shaft, which it has to do. I told you, I just tried to glue it. It laughed at me, and I ended up having to pull it all apart and figure out what to do. I just told you what I did. But look, I spent way too much time doing this. Like, it probably took me way more man hours than I wanted to. I could do the second one in like 2 hours. So, you know, I kind of think if I could do it, anybody could do it. Michael's instructions are good. He really didn't do this. You know, he didn't put the compression washers here the way I did, and he didn't shim this. You could get it to work if you didn't do those things. I'm just think this is a better design, a better way to do it, number one. And number two, it's a little tricky to get to work the other way, because I actually did, and I did get it to work the other way. And the reason I pulled it apart and changed it is I wasn't happy. Now, in a much better design is this gear that fits on the worm gear. There's nothing wrong with this. It's big old thick gear. Its set screw is bigger and has more surface area. It lands right on that worm gear just fine. Now, the other thing you should be aware of is the worm gear is in this worm gear bearing block that holds the worm gear and the bearings that are in the worm gear. And I'm not going to go into how to make an improvement to that. Michael talks about it. It's beyond the scope of this YouTube. But you would think to get that to go down onto the worm wheel, because now you've got the worm and it needs to mate on the worm wheel, because if there's slippage, you're going to just, even with the clutch tightened, you're going to have the worm not bite enough on the worm gear, and it's going to slip, and you're not going to be able to control your telescope, and potentially do damage to your worm. Now, you don't want it cranked down and too tight, and Losmandy's got a video on how to tighten that up, but I recommend you watch the video, and I recommend you tighten it up, because it's imperative that that worm gear sit pretty tight on the worm wheel, not cranked tight. But there are these little these little bolts on the top of this thing, and it's a little counterintuitive. You actually loosen the bolt up. That has the impact of driving this worm block down onto the worm wheel. So if you're slipping, you actually loosen things up. There's two bolts, you got to loosen them. But then you raise the two set bolts and then tighten it all back down again. And that actually has the impact of driving this back down. And, you know, just to kind of, you know, I actually just kind of got underneath here and manhandled the whole thing into the position I wanted, and then I cranked the bolts down. This will make a lot more sense when you're having trouble with your worm and your worm wheel slipping. If you watch this YouTube plus Losmandy's YouTube, you'll understand what I'm talking about. So you can hear this just, see, there's no backlash. Everything moves freely. Now, when you power this up, nothing's going to move because you've got, what, 15 or 18 volts here. I actually have 19 volts here. I've got this all powered up. Driving away. And everything's tight. Like, it's not, there's no backlash, there's no chatter. It's lubricated, so it's not grinding away. And I'm done. I like it. Like, I wish they put a metal gearbox on here to begin with, but they didn't. And my own view is, because I own 2 of these Losmandy G11 mounts. One is the regular G11 G, the regular old G11 mount. My mounts, I bought that mount used. It's got to be like 40 years old. Man, I had to pull it apart and basically rebuild the whole thing. But it works fine. As the old Gemini 1 controller. And again, this guy Michael's brilliant at fixing this stuff. So I sent some of that stuff to him and it came back. I think you can get away with a 35 or 40 pound payload with that plastic gearbox, and you'll never know. I mean, the performance is going to be better with this just because it's a little more high performance, and it's not plastic. It doesn't flex. It's the same and whatnot. And it's better lubricated. When I pulled this off, nothing was lubricated. And they're gears, and they, you know, somewhere in gear engineering school, they tell you should lubricate your gears. So between putting a good lubricant on there, the good lubricant makes a big difference. Just telling you. I mean, you know, my other mounts is out there now. It's a Paramount. Taking pictures tonight. Can't even hear it. Even when you're slewing it. Like, I slew it, and I'm like, is it slewing? Because I can't hear it, because I got it all really well lubricated. And my Losmandy G11T here, I've got it pretty well lubricated too by now. It made a huge difference. Like, it made all sorts of noise when I got it. And I don't mean noise as in, you know, bad noise. Just, it was very noisy, but I fixed the lubricating. It really made a huge difference. So I think you can get away with that plastic gearbox at 35 pounds, maybe 40 pounds of payload. And I have a optical tube assembly that I use that's probably about 35, 40 pounds. You know, I'm not changing the plastic gearbox just for that, even though the performance is better with this. But for my big heavy payload, like it just didn't work, and I had to do it. I'm going to get better performance out of it. And, you know, when April showers comes, and I take everything inside and clean it and do maintenance on everything, I am going to go put a belt drive in there. And you'll notice if you look at other heavy-duty telescope mounts, my Paramounts, Celestron heavy mount. I get one of those. Haven't used it for 15 years, but it's down there. You know, they all use these belt drives. I've never, I don't know why. Not only do they have this transfer gear, so you've got the worm gear driven by this. You've got this transfer gear box. You got the motor gear box. That's a lot of gears. So what you normally have is just a motor drive driving a belt, and the belt drives the worm gear. So you have the worm gear and a belt and a motor. That's a lot better than a motor, 2 gearboxes, and a worm gear. But what do I know? So I hope this has been, I'm sure like there's like 0 people are going to watch this. But if you want to change this gearbox, you should watch the video and get a hold of Michael's papers and you know, pay close attention when I did, because like this didn't take me a minute to figure out how to do. And I think I just communicated all the lessons learned. Didn't cost me very much, $35. I had most of these tools. I mean, even if you didn't have them, you're looking at under $75 of tools. So it didn't really cost very much to do. I don't know. I might do the RA on my G11 G. This is my other G11. But I don't really use that for anything other than I use it when other mounts are broken. Then I need to go use a spare mount. I use this as my spare mount. If you have a payload that's over 40 pounds, I definitely would fix this in the RA. And if you have the T, if you have the you know, these plastic gearboxes are in the this is the Titan G11T version of this RA drive. It's what I've been droning on about. But they have this plastic gearbox in the G11 Gs too. But if you're driving you know, whether you got the T or the G, and you're driving a payload over 40 pounds, I would fix it, because your performance is going to really improve a lot. And secondly, that plastic gearbox is going to blow up on you someday anyway. I hope you found this helpful. You know, feel free to reach out if you have questions. I mean, I have a machine shop guy, and I almost threw this shit in a bucket and went over to the machine shop and said, hey, you know, like, you know, you're the pro, do this. But I held out and I got it done myself. And I do like this Losmandy stuff. Like, there's a few, like, I'm going to do a review of these mounts, these Losmandy mounts. It's going to be generally positive. They do look nice. There's some really idiosyncratic features that you know, you might have to get to know, like, this plastic gearbox and how they control how this worm gear lands on the worm wheel for the Titan RA. And like there's half a dozen things that are a little unusual in telescope mount land. But I hope you found this helpful. And I'm going to go back to see how my data collection's doing.